Hi, everybody. This is Joanne with Read Science, and we are so privileged today to have two very accomplished women with us who have collaborated on a book series. Of course, I'm joined by my guest, Jeff Schomeyer, and today we will be talking to Penny Chisholm, Dr. Penny Chisholm at MIT, and Molly Bang, who is an illustrator and book writer. She has a lot of books to her name. So I will introduce Molly momentarily, but let me just show you these books very quickly. So Molly wrote a book called My Light, which I do not have. I should have run to the library. But the first book I was introduced to was this one from Penny Chisholm called Living Sunlight. And Penny had come to the University of Illinois to give a talk for the Carl Woese symposium that we had there. And immediately I fell in love with her talk. And when she said she had some books, or I looked it up on YouTube or something, I was like, oh my goodness. So this is How Plants Bring the Earth to Life. Someone can maybe tell me which one was second or third, Ocean Sunlight or Buried Sunlight?
Buried Sunlight, I think.
Ocean Sunlight was second, Buried was third.
Okay. Ocean Sunlight, How Tiny Plants Feed the Seas. Buried Sunlight, How Fossil Fuels Have Changed the Earth. And then the most recent, which prompted me to make sure to contact Penny to get them on the show, is Rivers of Sunlight, How the Sun Moves Water Around the Earth. And we are interested in talking to our guests about their collaborative work. These beautiful books that introduce topics, obviously, such as photosynthesis, how matter and energy cycle through the earth. And we've got the origins of life, we've got climate change, we cover everything in these books. And actually, my son is an atmospheric scientist, and I think I want to send him Rivers of Sunlight. Because I think that's exactly what he works on. So let me quickly introduce Molly Bang. She has a fascinating life that she has led, and I won't go into all the details. She is an illustrator of many, many books, including many science-themed books in addition to these. And but we have a few things in common. Penny, now I didn't major in French, but I studied French for many years. And then I also worked in Japan. I didn't teach students, but I worked in Japan. Though it sounded like you had much more interesting time because you covered space launches. And yes, so you had a career as a journalist and switched over to become an illustrator. And your mother was a medical illustrator. So I think there was a little influence there.
There sure was.
And yes, everybody say hi to Molly. And we have, you have won several awards, including the Caldecott Honor 3 times. And then the two of you together have won several prizes. And we will make sure to link to your Living Sunlight series, Sunlight series on your website underneath, so you guys can check out all the books there.
Oh, good.
So, welcome, Molly. We're glad you're here.
Thank you. I'm glad to be here.
And it's my pleasure to introduce Penny Chisholm, or S.W. Chisholm, as she's known in the scientific world. She's in the biology department at MIT, on the faculty there. And I loved the summary headline that I saw in an MIT Technology Review article called Understanding the Ocean's Smallest Creatures, because this is what Penny is all about. She's devoted her life to something that Joanne warned me I'd better learn to pronounce, which is Prochlorococcus, which Wikipedia and the online Google told me is a small cyanobacteria and perhaps the most abundant photosynthetic organism on Earth. And I don't think I'm just making it up to say I've always been fascinated by all those cyanobacteria and what they did to the Earth's atmosphere that led after a long time to oxygen-breathing animals and all the rest of that. When I looked at the list of publications from the, quote, Chisholm Lab, I found 188 results, and the word Prochlorococcus figured very prominently in it. These publications stretched all the way back to 1973. In fact, a few of them were listed in year 0, but I wasn't sure what year 0 might might be in this case. Welcome, Penny. It's nice to have you here.
Well, it's a pleasure to be here. Thank you.
There's so many things to talk about, but one place where I wanted to start is by mentioning that in all of these books, they're told in first person by the main character, who's the son, which I thought was a very interesting perspective, that the son is telling the story. But also I noticed after a while that this young person, if you can see, if I get it right, this young person figures very prominently. And I think it's not quite true that this person is in all the illustrations, but this person is in many, many, many of the illustrations. And I have some theories about that, but I thought I'd ask you to start by telling me a story about this person.
That person is every person who is reading the book. I wanted the readers to identify with the child, but the reason that I came up with the idea of the son speaking is that when Penny and I were first discussing these books, we wanted them to give a sense of awe to children because that's what both of us felt. And also, Penny and I found out that we had both loved the book Paddle to the Sea when we were little. And it's a story about a little boy who can't go very far, I think, Penny, do you remember where he starts?
The book is about the Great Lakes, which is why it was really important to me, because I grew up on Lake Superior. So it's a little boy carved Native American in a canoe, and it goes all through the Great Lakes and the St. Lawrence Seaway, and so it's all about the area of the states where I grew up, which is what drew me. The only books we had as a kid, not because I was deprived. I was not deprived at all, but simply I didn't live in a booky household, so that was my favorite book and one of our.
So anyway, do you have more to say about this kid?
Well, I wanted the kid to be identifiable by any child who read the book. So that's why I made it with brown skin, black hair, not racially identifiable.
And why I haven't used a gendered pronoun yet, which gets a bit tricky after a while. But
well, that's it, because I wanted it to be a non-gendered child. I wanted girls to be able to see it as herself and a boy to be able to see it as himself. So you're right on.
And that's something I think you can see through all of Molly's books. She does that, which I think is an incredibly effective thing.
And then for Molly, and she knew that this idea was coming, but I read in one of the fly leaves that you've written about the meaning in design and in how artistic images are arranged. And I thought that was very interesting. And excuse me, I wanted every one of these pictures, there's so many, but here's one example perhaps, where there are several things that come to mind to me to talk about these things. One is the number of stories that are in it, but I want to get to that later. But the one that really struck me is that I look at this as a grown-up, and two things happen. One, I see the stories that are going on and how we're looking at how the sunlight does things. There are circles, there are creatures who sometimes eat each other, eat plants, do all sorts of things. And yet the picture tells a realistic, very scientific, very carefully scientific story, but it doesn't do it with artistic realism. It's very metaphorical. Particularly throughout the books, you use little yellow dots, as you mention it, to represent photons and sunlight. Do you have, where is that line? It may be a quest now for me to understand. I want to understand how it is that children seem to understand fantasy and metaphor so easily and not get it confused with reality, whereas adults are always concerned that kids are going to confuse fantasy with reality. I don't even know what the question is. It's a discussion idea, but these pictures are all very metaphorical, poetic, I would say. But I think easily the meaning is easy for the kids to understand too. Do you have a method? Do you have a point? Do you have some insights, or do you just draw pictures?
Okay, the difference between the metaphor and reality, I'm not real sure about how to distinguish those, but the yellow polka dots started out because we think of light, we think as either or, as far as I understand, as either individual packets, photons, or as waves of energy. And so I put them together as waves of a whole bunch of little yellow polka dots.
And we can see that here, for instance, where you have a schematic picture with the Earth and the sun, and here's light coming from the sun, sort of as waves, sort of as photons. But, you know, when I put on my scientist hat, I say, well, that's not how it goes. And yet it doesn't mislead me in any way, which is a very important thing for me reading a science book.
And I guess the other part about the style is simply that I wanted the pictures to be as clear and dramatic as possible. Again, going back to Penny and my wanting to make the books awesome, so to have children feel awe and wonder when they're looking at the pictures, I wanted them to be simple, factually as close as possible, and dramatic. And so the simple and dramatic I could get, but then Penny had to check every picture for its scientific appropriateness.
The irony there, though, is that remember there was one picture, Molly, I can't remember what it was. I wanted to get the science so right that you were, it was too realistic, and I kept saying, it's too realistic.
Yes.
And the irony is
what happened,
realistic, and the artist wanting to make it look like I forget which picture that was.
It was photosynthesis. It was something
that was one. Yeah, that was one.
Oh, that was
in buried sunlight. I can't remember, but anyway.
But that's where the sunlight.
That's where the partnership, I think, really works very effectively.
Yeah.
We temper each other's tendencies to want to go in the other direction.
Well, when I've found over time that when I'm evaluating for purposes like this discussion, how I see the science happening in a book like this, the most important thing seems to me that there's nothing said in it that's misleading. You can't tell everything there is to tell, even though there's an abundance and you manage to fit in a lot of stories. So completeness doesn't quite come into it. A coherent story is good, but I feel like maybe the most important thing is being careful not to do anything that will lead the person down the wrong path and ruin them for the next 17 years. So how does how does that feel to you, Penny? I mean, I felt very good, and excuse me, that's my mystical questions. Like, this is very metaphorical and everything, and yet the science feeling that I was deriving from thinking about these pictures was very coherent and also not misleading.
I really appreciate your saying that, because I think that was the biggest struggle for me in writing these books, was line between having them accessible and hopefully interesting, and yet not violate what we know to be as much as we have truth in science. And a lot of these subjects, I'm not a deep expert in a lot of the things we're covering in this book, and yet I'm surrounded by colleagues who are. So them in the back of my mind saying, you know, no, Penny, you can't say that. That's too oversimplified, you know, for every little thing. And so we struggled a lot with helped forth with Molly to get it right at that sweet spot where it didn't violate my, my understanding of how the system really worked, accessible. But that was I think the biggest struggle, and that was why we have the notes in the back of the book.
Great touch.
If there were oversimplifications, I could always say, "Oh, I can fix this in the back of the book." At least I can say, I can say, "Well, these are the things we oversimplified."
So you discussed these matters, you and Molly, in the early stages of making the illustrations.
We discussed every picture. Well, we worked together on everything. I mean, Molly played a big role in the writing, and she always bounced the pictures off me, and would this amazing capacity and willingness to redo an entire. Our methods are completely different. Like, I'm very linear, and she's willing to paint a whole picture and then redo the whole picture. There were a lot to get them to that sweet spot.
And I think the way, to give a general idea of how we worked is, for the pictures, Penny would pretty much figure out what the story would be, because she knows what the main points would be. And then I would try to translate that. We'd try to figure out how we were going to fit that story into 40 pages. And so I would do a dummy showing how the pictures would flow. And then Penny we'd go back and forth on the dummy, trying to figure out if that was going to work. And we kept correcting the dummy. And then we developed both the dummy and the words. The words were pretty much developed at the beginning. And then we kept playing back and forth with what the words would be. And then pretty much I started the pictures from start to from like page 1 and on and on and on. But then we changed the words as the pictures got made.
Sure.
Over and over.
Yeah, I believe that. There's a couple places where, it's funny. So I teach, and we'll get to your impetus for this book, but I teach a non-majors biology class here at the University of Illinois. And I know very well all of these people have gone through high school. They should have learned this, right? But yet we still have to teach this material, because we're introduced to things in high school once, you move on. Supposedly that's enough in life, but it's not. And I had a brief chat with Molly when we were testing the system yesterday, and we were talking just how wonderful this book would be for adults, to revisit. So I read something somewhere on the internet, Penny, that your impetus for this book was you're teaching a class and realizing your students weren't getting the concepts or something like that. Is this correct?
Yeah, I think it's hard to figure out exactly how it all happened. I mean, Molly and I have known each other for long before we started these books, and I watched her make a lot of children's books, and I was concerned. I think the initial concern was about how people didn't understand the system and the global carbon cycle, and that if you don't understand the role of plants in the global carbon cycle and the role of the biosphere, it's impossible to make good decisions about burning fossil fuels, etc. So talked about doing a book on the carbon cycle, and that was where the paddle to the sea story, that we thought that the carbon atom could be the paddle to the sea canoe, and we'd follow the journey of the carbon atom through the carbon cycle. Talked about that probably for a year or two, right, Molly?
Oh, easily.
And we just couldn't, it was just my image. Molly and I, we could not map ourselves onto the same picture. And then, so it sort of started to boil down to photosynthesis being at the core of that. Gave up on the adventures of the carbon atom. went photosynthesis, and that's when instead of the journey, we let go of the journey part of the story. Anyway, ultimately, that a lot of that was incorporated into buried sunlight, but that was
Right.
this
It's very
long
impressive.
journey getting to living sunlight.
Mhm.
You
And the
know,
other thing-
oh,
the-
go ahead, Molly. Go ahead.
The other thing I wanted to add is you're talking about your students not knowing some of these scientific concepts. I didn't know the basic concept of every single book before I worked with Penny. And my parents are scientists. I'm very comfortable with science, and I thought I knew a lot of science. But I didn't know each of the individual, I didn't know, for example, I didn't know that we're made of carbon that comes from the air. I didn't know that. I thought, like most people, that plants draw up their existences, their leaves and everything from the earth. Had no idea that they pull it out of the air. So every book had a really basic concept that I was clueless about.
Is that something that gave you a leg up, as it were, in talking to children for whom these ideas might be new? Do you think a fresher perspective?
Gave me total sympathy, that's for sure.
So sometimes you're the little person in the pictures.
Oh, very much so.
Yeah. You know, actually, there's a couple of times you have some words that sound like a process. Crack, kazoom. You know, and I was like, hey, I never thought of this, you know, the reactions in the chloroplast as having sound, but I thought this is very effective for kids. You know,
I was really enamored of comic books. I still am. I think comic books are an incredible way for kids to learn. For all of us, I love comic books. They're great. And so I was very influenced by various comic book techniques. So using the little rectangles to show process from one thing to another, using words like crack or whatever, using inserted pictures that go so that you go from inside the frame of the picture to outside of the frame of the picture. All sorts of things from comic books, I think, really helped things work.
Yeah.
Here we go. We've got sugar, you know, so there's no doubt what's being made.
Exactly. And those little inserts are
Exactly.
1, 2, 3, 4 are very much like what they do in comic books.
There we go. Crack.
Yeah.
Which
Yeah.
must be a familiar way of talking about it, because I noticed these and now I think about them, and this is my obsession again. And sometimes the inset is like a magnifying glass. Sometimes it's showing a progression, a sequence of 100 billion years in time. Sometimes it's just a little extra view over here. Sometimes it's because the Earth is far from the sun. But we don't have to explain those things. And now I find I want to know how it is we can possibly figure out those things. And I'm not sure it's because I've read so many comic books, even though, as you say, that method of presenting things is very familiar.
Yeah. Yeah. There's a great book.
Picture that you just showed that has all of the molecules that are realistic, sugar and all of that.
Yeah.
There's an example where to Molly, they don't have to really be sugar molecules, but she's absolutely right. I mean, it's much more powerful in that case that they actually are molecularly, not that a kid is ever going to recognize that right away, but sometime down the road, they'll realize, hey, in that book, they actually had it right.
As I would sometimes say, my inner Sheldon says there's no reason it can't be right.
Exactly.
Right.
And
here we go. It's breaking apart the sugar.
They may not learn the structure from that, but you're so right that having had it correct the first time they see it is a great advantage. I think a very important thing, even if they don't take that as semantic meaning or something.
And
I think that's where Molly's love of science comes in, that she will make the effort to actually do that. Her respect for the realism, I think, makes a big difference in the books.
And that's why we feel that they're just as appropriate for older kids.
Mhm.
And one of the ways that we have them, or that we've seen teachers present them, is we know you already know all this information, but just as a review, why don't you look at these books? So pretend that they know it, knowing that they don't,
Right.
and having it shown really basically and simply. And one of the difficulties Penny and I had the most trouble with was showing photosynthesis. And we thought of it as going around in wheels somehow or other. And I showed it with all of these wheels going around. I was on vacation. I took off all the time on my vacation. At the beach, I would stay inside. Everybody was at the beach. I was drawing the last because we had to meet a deadline. And I finished it and triumphantly brought it home. And Penny looked at it and she said, "This does not work."
Yeah.
And it didn't. So
And Penny can say, "I saved you from a lifetime of melanoma because I kept you out of the sun."
there you go. Yes.
Well, isn't it amazing sometimes what a struggle it is to get to something that seems so obvious after you've done it?
Yes. Yes.
Yeah. Now,
Yeah.
I'm imagining when I was looking at this, and so there's another aspect of these pictures that you know, the richness of them, in addition to the correctness. I'm imagining that in many cases there might be a young reader being assisted by an older reader who is helping guide the young reader through the book. And so I can imagine that the older reader might be reading the words aloud, for instance, while the younger reader is looking at the pictures. And so I'm thinking a very important thing, and here was just one example, but it happens so much, that all of these pictures have lots of little stories here and there. And I think surely that's an important aspect too, because there are things for the young reader to look at while listening to the words, and they start going in poetically as well and matching up. And then there are things to talk about on each page and to tell stories about. And when it comes down to it, telling stories about science is how we learn things, right?
That's what we think. And the other is that little kids look at pictures much, much more than the older you get and the prouder you are of being able to read. And then once you can read, we don't look at pictures at all compared to little kids. So
do they look at them narratively, do you think? Are they looking and seeing these little stories? That seems to me like they might, and there's all these little stories and things going on, and that must be so much fun to look at while you're listening to the words.
I have no idea. All I know is that we try to make sense of everything that we see. So I'm sure that starts with little kids.
Mm-hmm.
Right.
Mm-hmm.
Well, so the first time I heard of Penny was when I saw her giving a talk, and I felt, of all people at the talk, I'm a biologist, so I'm understanding what everybody is saying. But your talk was the most accessible, and it had a vibrancy to it because you were telling the science, but you were also making it relatable. And even as scientists appreciate good storytelling, good imagery, related to real life. You had a slide in your talk where you're talking about, I believe, the genes in Prochlorococcus and apps on the iPhone. Is that correct? Am I remembering that?
That idea was an idea of one of my graduate students. I have to give her credit for that.
Well, congratulations to her.
And ironically, she had that idea when we were having a group meeting, and her name is Katya Moniz. Ironically, a year later, somebody actually published a paper on that. That said, cell phones are bacteria and apps are genes or something. It was a title. They published the paper on it. So it's interesting. It's a concept that has parallel evolution.
So this is why they're called cell phones.
There you go.
Maybe.
Maybe.
So I felt like right there as I'm listening to your talk and I find out you have storybooks, I knew it would be a good storybook. So it's, here's Molly's the illustrator, and Molly has this love of science, but Penny, you're the scientist who has this way with sharing the ideas. So I think, you know, somehow, you know, it's just melded so beautifully into these books. Yeah.
Oh, thank you. We hope so.
Yeah.
It's certainly a very effective partnership in the complementarity of
Mhm.
of
So
our world.
from start to finish, so I'm looking, Rivers of Sunlight, you had said when, I forget, it must have been a year and a half ago, maybe you had come to campus, you said a fourth book would be coming out. So it was from start to finish, how long does it take, you know, to do this? So you've got 3 books together, I guess 4 maybe with My Light. So then does it get faster with each book?
4 books together.
Yeah, there are 4.
Four together.
Living
But Molly has a book called My Light.
Right.
Yes,
So
which is-
that's fifth.
a 5th one.
Yeah. So these 4 books in the Sunlight series. So about how long does it take? And has it gotten faster with each book, or has it actually taken longer with each book?
From what I think, Penny can
I'd
correct
say
me,
about
it's about a year.
Yeah, I would say
plus?
about a year. From a year of working, then
Yeah.
it takes the
Mhm.
publisher more than a year for it to come out. But it's a year of our working on it together, and it probably could be quicker if we place half of the year. We're in. We have a summer place in Woods Hole, and Molly's in Woods Hole for 6 months, and then she goes to California, and I come.
Yeah,
but we work pretty steadily on it when we're in the thick of it.
And we email each other back and forth. We have something like 150 versions of Rivers of Sunlight.
Wow.
So
Every single word gets
Yeah.
written and rewritten, and
rethought.
and the pictures, Molly redoes things often, very often. Time.
Some people have the naive notion that a book like this that has only 400 words in it must be easy because it's only 400 words, right? They don't understand how hard short
The hardest thing I've ever done is try to get this stuff. And you might notice that the book's wordier and wordier as you go along.
I did notice.
I did.
Yeah, I know, and I don't know.
Yeah.
But we tried not to let that happen.
Yeah.
But it needed to be described. And I see we've got the young child on a canoe riding.
Yep.
Yeah.
Yep.
Kayak. Yep.
Yep.
Kayak. Yeah, that's right. We had to get that
Had to get the child in every. In Rivers of Sunlight, the child is in every page, doing something that reflects, that mimics the action of the water, of the sunlight and the water.
Well, that's the closest to paddle to the sea that we've gotten.
that you got. And then here's fella up here, or I shouldn't say fella, the child up there in the sky. Yeah. So it's amazing. And when I like I said in the introduction, like I said, I read this book and I thought, I'm sending this to my son. He studies something like heat from the ocean making clouds or something. I don't want to misrepresent. Oops.
Sorry, I lost you for a minute. I don't know what happened. Something.
I see. Yeah, it was like suddenly there were 2 of you.
It just went out.
How interesting.
I'm back.
Okay, I can maybe eject this person. Hold on, if you go away.
Choose the right one.
Yeah, exactly. Well.
She'll go away sometime, yeah.
Okay, Penny, are you still there?
I'm here. Can you hear me?
Yep, gotcha. Yep. Okay, no, there's just 2 images of you.
Well, yeah, I know.
That's okay. It's not the end of the world. We just
let me.
I tried to eject, but it said no, and I think that's probably for the best.
Yeah, I think it's all right.
We're good. We're good.
To make that connection with my earlier inscrutable remark and about Molly and the semantics of images and stuff, there was one picture from Living Sunlight, which was the first one in this group that I have at least, that features the child. And, maybe it was awe that it inspired when I looked at this picture and I saw this circle here. But the circle doesn't exist in fine form. It's made up of all of these parts that contribute to the circle that the child is inside of. What did you think of? What were you thinking while you created that circle?
The circularity of carbon's trip.
Mm-hmm.
And the circle that makes life. So that we are inside of and part of the circle of life. And that's why Living Sunlight emphasizes so many circles, because from what I understand, and Penny's going to have to correct me on this, that the molecules go around, the carbon goes round and round in circles. The energy comes through. So that the energy from the sunlight comes through the earth. It affects all of the molecules, but it dissipates with each molecular change. And then it goes out and disappears away from the earth to energy that can't be used by us on earth anymore. And so we had this double movement of things going on, of the circularity of the molecules and this straight line of the energy, but the energy is incorporated in the molecules. So
uh-oh. Is that just Molly or?
Yep.
Okay, Penny, are you still there?
I'm here, yeah.
Okay, so Molly's car may have run out. So maybe you can help with that. So she's talking about the circularity of carbon and the straight line of energy, if you knew where she was going with that.
Well, and I was thinking, it is an amazing story. Yeah.
I've lost the image. Hold on a second.
Okay, I see you.
Are you there?
Yeah, I'm here.
That's interesting.
And I can see you and hear you fine.
Yeah, we can see and hear you.
I can't see you, but I can hear you, so I'll just keep going.
Very strange.
That's an interesting topic, because in I think the last picture which you showed in Living Sunlight,
with the circle,
everything goes round and round.
Yeah,
round and round in a circle or whatever.
Yeah.
After that was published, I worried that energy can cycle.
Yeah, I understand that there's that it's perpetual motion or something.
Exactly. And I realized, see, that's the kind of thing that, oh goodness, we're going to get killed. But the other thing, in one of the books, either that one, I think it might have been that one, we should be including entropy and in terms of this energy business. And I struggled with that, and I just, it's such an important concept, but we just let that all go. Maybe that would be another book at some point. But
I can see the concern, but I think because you stuck to sort of telling the complete story, that and got it right, didn't do misleading things. You're talking about the sunlight. I think it was fairly clear that there is an amazing story that's carbon dioxide over here being photosynthesized and used by the plants, with water being taken apart in all of this, and oxygen up here, and then humans over here taking things apart, and everybody making carbohydrates. But I don't think that question quite has time to grow, of the perpetual motion, because of the sunlight. That's the theme. You've got the sunlight, and I think we always, when I was reading, at least I had that always in mind. It's like, this is amazing, and it keeps going round, but it's not perpetual motion because you've got the sunlight putting the energy into it.
Good. Okay.
Welcome back.
That's a relief.
So I felt like it was a good telling of the story, and it is such an amazing thing, because plants they're not interesting, they don't move around or anything, but it is so valuable to see them as the second half of the hemisphere of this circle, that they're critical to everything that we do.
Well, this was one of my big motivators, is that at MIT, biology is very focused on human biology, and it's another reason I books is that people just don't appreciate how much our lives completely depend on plants and photosynthesis. In fact, if you put photosynthesis in the course catalog at MIT, nothing comes up.
Right.
Like, and you know, it's fine. We're focused on human health, but want the world, and in many ways, Molly and I have, not just for children, but just for people, to have them appreciate the role of plants in shaping our world and, you know, everything that's meaningful to us. So,
well, this is your, you know, your big core contribution and your viewpoint from your interest in the Prochlorococcus and these cyanobacteria and the contribution they made through deep time to give us an oxygen atmosphere and sort of bootstrap this circle of photosynthesis, human animal breathing and metabolism and things. And so you know, is that way back? Is that where you're coming from? It's a great story. And is that, I don't know, is that you and cyanobacteria? Is that why they fascinate?
Yeah. Well, I think for sure that my interest in this obviously comes from working on and phytoplankton scientific career. I worked on these microscopic plants and been inspired by them. So I think that obviously influences action. And interestingly enough, the first book, Living Sunlight, you know, we wanted to cover both plants on land and water, the phytoplankton, but there just wasn't room. So that's when we had to write the second book on ocean sunlight to cover, and then we just kept going.
Right. So I think, you know, I'm looking at buried sunlight, for instance, and you talk about the origins of life, and you talk about fossil fuels and climate change. So you know, in a way, I feel like this book might engage people in the hot topics. I mean, you know, if there's any controversy in any book, this one would have it, perhaps.
Right. Exactly. Yeah. We tried to have it just be factual.
Right.
Good, and not get into the controversy. But the goal with that book, it was to describe why we have fossil fuels and how long it took to make them, and the fact that we're using them. It's all about the rates at which we do things.
Yep. Here we go.
Because we're using them in such a short period of time. That's why we have a problem. And we tried to emphasize at the end, you know, that this is a precious resource that isn't being renewed, and we can use it like we use other Earth resources, but rates that we're using it. That's sort of the point we tried to make. And I think if we were to write another book, I haven't figured out how it would come together, but I think that's the biggest thing that people don't understand is it's the rates at which we do things, not particularly what we do, that causes environmental problems.
Exactly. The fact that we do it is not so bad, or the Earth does cycle. So actually, I love the hockey stick, his representation. I was like, there it is. So it's amazing. I just love, I had read these a while back, but I just sat there last night in my bed and kept looking at the pictures and rereading and just enjoying. But I felt as I was reading that buried sunlight really was the one. Boy, do people need this.
Except, it's another sign of our inflexibility once we think we understand something. That of the reviews we've had for the book, there was one specifically that I remember that said, "Oh, that's too bad. I really loved all of their books, but it's clear that they've been taken in by the hoax of climate change." So we tried to make it, Penny tried to make the science as completely clearly scientific as possible.
Neutral. This is just what we know. This is what we've measured.
Yep.
Right.
While Molly's there and we're talking about rivers of sunlight, it's only a few years ago when I was reading about, I don't know, deep time and climate and things that I learned about the, talk about awe-inspiring, I don't know, the surprises of the, North Atlantic conveyor belt.
Oh, yes.
It's like, were you so amazed by that? And I still look at it, I'm thinking, 10,000 years? How can that be?
Jeff, I was blown. That was the one part that I was totally blown away with. I still, for something to drop, for a huge river in the ocean that is something like 25 times the amount of water as in the Amazon, to just be constantly dropping down there 2 miles down,
Yes,
freezing cold water, that it becomes the engine driving this current of water all around the earth, is just so, it's miraculous. It is amazing.
it is. And the thing that, to be serious, the thing that keeps me awake at night when it comes to climate discussion issues was reading that, and reading that I understand from my physics background, I understand nonlinear phenomena and how, 4 degrees temperature change can have serious effects on some processes. And the one that I was reading about that keeps me awake is like, it looks like a few degrees change, and we don't know how much, can shut down that conveyor belt. And it can shut it down in something like 120 years. And once it gets shut down, it may take another 10 or 20,000 years to get it started again. It's like, that is a huge and alarming nonlinear problem. And that, if I need something to worry about, that's usually what I settle on.
Yeah, that is a big concern.
I like this here. I mean, I feel like, you're teaching something on every page, not just about the bigger concept that this is the ocean conveyor belt, but you're saying salty water is heavier than fresh water. Cold water is heavier than warm water. I mean, I just like, even if the kid sort of embeds that, that's going to help them in chemistry and physics down the line,
And that's what we love.
The other
One of the things that we really enjoyed was making up class activities, or reading about them and finding out what other people had done and putting them in teachers' guides. Yeah.
Oh.
The other thing we put in that book, which could be controversial, but I thought was really important to put in the book, is that vapor is an incredible greenhouse gas.
Yes.
And it really important for maintaining that we have, and that understanding the water cycle is central to understanding global climate change. And I snuck that in the book because I felt that it really is important. I think it's just in the notes. No, I think it's in the book.
No,
itself.
it's in the book itself.
Yeah,
It's in there. It jumped out at me. It jumped, believe me,
good.
I saw it.
Good.
And I knew it, but I was like, ooh, she put that in. I was waiting for the cows, though, and the methane.
Well.
Yeah, I know. That would have probably made more kids like the book. Cows farting, but
Cows farting.
Yeah. And termites, don't forget termites.
Couldn't get
One of my
that in.
favorites. Yeah. But that sort of support, science support that's like almost in each sentence, but is, can be in the background, is something that I think Joanne and I can agree we really value, and it's in all of these. And I also really appreciate the 2 or 4 pages of notes on the book, where you talk in a more expository fashion to, I imagined it as, to the people who would be the adults who might be telling the stories, that gives a little more the next level of detail to someone who wants to read it. I thought that was a very valuable contribution in these books too.
Right. Magnificent.
Oh, thank you.
So we have a few minutes left, and I want to make sure we didn't forget to ask you something that you really wanted to talk about. With regard to these books, I'm very impressed, and I've been sharing them a little more heavily at this point since leading up to this. But I'm always telling teachers about this series.
Oh,
and hoping they adopt them.
Well, we really appreciate your enthusiasm for the books, and after this conversation, I appreciate it so much more because you clearly made me feel like you were there when we were writing the books. I mean, that you could what we were doing, which is it's always incredibly validating. It's wonderful to hear. We haven't had this, this kind of reading before,
Cool.
feedback at least. So this is really great.
They're very satisfying, and do everything that we would like stories about science to do, I think.
Exactly.
And what about you, Molly? Anything nice you'd like to say to us now?
Just I appreciate everything Penny said. I totally agree with her. The only thing that I'd like to add is that we really had fun doing the books. It was like we were it was really hard to work together at the beginning because, as Penny said, we have such a different way of approaching life and approaching our jobs. And so that was really hard. Once we understood better how each other worked, then it was easier. But just the whole challenge of two people from such completely different backgrounds working together to make something they both wanted very much to be the best they could was really fun.
I think figure skaters would tell us that good things that look easy when they're done are never easy getting there.
Yes.
And
Yeah.
that's an interesting truism, but it sort of makes it worthwhile, I think.
Yeah. It was hard, very, very hard, and very, very fun.
But so hard and so fun, you'll do it again, you think?
Yeah.
Molly's on sabbatical.
I see. Oh, well, thank you for joining us on your sabbatical.
Right.
I don't
we'll see.
I don't see how they can not do it again, really.
Well, Penny's already come up with a possible subject, so we'll see.
Good. Good.
Yeah,
Well,
which we have absolutely no idea how to do it, though. None.
Yes.
No idea whatsoever. So,
well,
incubation.
if you ever get it in your head that you want to do mitosis and meiosis, let me know, because my students are always convinced they know meiosis, and
Not so.
That's
reality
sounds very
tells me
hard to me.
otherwise. So,
Okay, Joanne.
yeah, this has been wonderful. I'm so happy I got to talk to both of you, because I really do appreciate your book. And
that we finally had a chance to talk about all of these books too is a very exciting thing.
Well, thank you for your appreciation and your enthusiasm, both.
And also, I want to say that the website for the whole series is called thesunlightseries.com. But we're in the middle of redoing it, so it might not come up. But at some point, it will.
It will.
Okay, the Sunlight Series. Well, we'll be sure to put it in all of our, sharing, like under the video.
Okay.
And on the podcasts, we make sure that people know where to go.
I have a final thing to say that I just remembered, which is I was at a photosynthesis conference selling the books, and many of the researchers came up and said, "Oh, thank goodness we have these books. Every time we try to tell our parents and our family about what we're doing, their eyes glaze over. These books are going to solve our problem."
Yes.
That's so good. Well, that's the thing. I'm going to ask my son, is this what you do? Exactly. It's because sometimes he'll say things and I say, you're saying words and I'm a smart woman, but those words don't belong together.
Yeah. Well, and even scientists, we like to see ourselves in these books too. So
it's true. Yeah. It's true. I feel so happy that I went to the Carl Woese Symposium and saw you there, Penny.
Well, it's a pleasure. I'm glad you were there.
Yeah, and I just, and then finding the books and talking to you both has been really delightful. And I'm glad, despite tech issues, we had a lovely chat.
Yeah. Thank you.
Thank you.
Thank you both for being here. Thank you to everybody who tuned in. And yeah, whether you have children or not, find the books, take a read. They're good science and beautiful pictures. Okay. See you next time on Read Science.
Bye,
Thank you,
Joanne.
Jeff.
Bye, everybody.
Bye-bye.
Bye-bye.